And what is the relation between these two? These two are positional isomers. Hello everyone, welcome to PLUTUS STEM. So we are going to discuss today regarding the functional isomerism. So as you are aware, those who are watching this channel regularly, that we have already discussed regarding the chain isomerism and position isomerism. In the previous lectures, we have discussed regarding these two isomerism. In these, we have discussed in quite detail how we can find out the chain isomers and position isomers, what are the similarities and differences between these two isomerism. So how if sometime it looks like this is our Cl over here and a Cl at this side. So is this a chain isomers or a position isomer? That all things have been discussed in the previous lecture and many more complicated problems. So today we are going to discuss regarding these functional isomerism. So as we know that isomerism, we are having same molecular formula but a different structural formula, because it is a sub part of structural isomerism. So different structural formula, but in this functional isomerism, the structure will be having the difference due to change in or difference in functional group. So we have already discussed regarding this functional group also, what is a functional group. So today we are going to just see there are various groups are there that are interconvertible into different isomers like alcohol and ether. We will see a first example of alcohol and ether. This is a functional group which is being represented by ROH and this is being represented by ROR. So if we see over here how we can see some isomerism in these two structures. So if we are having C2H5O, C2H5O, 2 carbon, 5 hydrogen and 1 oxygen and OH like this, C2H5OH. This is the molecular formula, or you can also write that C2H6O. This one or this one, and this is the molecular formula. If you wanna see over here, if you draw the structure, this is CS3, OCS3. This is the ether compound, or we can say dimethyl ether. Dimethyl ether. It is a dimethyl ether. And if we are going to draw a similar type of compound, a very simple compound, CS3CH2OH. This is ethanol. One is alcohol, another is ether, and both are having the same molecular formula but different structure due to this change in different functional group. You can visualize over here 1 carbon, 2 carbon, 3 or 3,6 hydrogen and 3 to 5 or 1,6 hydrogen. So both are having the same molecular formula but different structural formula. Such type of isomers, they are being termed as functional group isomerism. So we will see some more example of this type of isomers. OH, and if we ask to draw a functional isomer of this compound, so we can very easily draw. It is having 1, 2, 3, 4, 5. 5 carbon are there and 1 OH is there. If I am being asked to draw the functional isomer is this, so I can draw it like this: 3 carbon, 1, 2, 3, 1, 2. 5 carbon are there, 1 OH is there. So if you see the molecular formula of this compound, 1, 2, 3, 4, 5. C5H12O or C5H11OH. So 336 to 336 2 2 2 4 2 6 6 or 6 12 over here 3 or 1 4 2 4 6 8 8 or 4 12. So we are having 4 hydrogen, sorry 12 hydrogen, 1 oxygen. So this is this one and this one, these two are functional group isomers or functional isomers of each other. Any other possibility can we draw from here? Yes. This one. 1 2 3 4 methyl butyl methyl ether. Or you can say IUPAC name of this methoxy butane. This one will be ethoxy, sorry, ethoxy methane ethane propane. So 2 3 in this side we have drawn 1 4, total number is 5, so 1 4 and 2 3. So I don't think there is some other more possibilities are there. I think we can do 1 2, and if you do some other thing, then it will give rise to 3 2, that is quite same, or 4 1, that will be also the same IUPAC name. So this one and this one is also a functional group isomers. Regarding these two are metamers. This we are going to discuss in the next lecture in quite detail about these metamers. So I am telling you that these are metamers. This one and this one, these are not positional isomers. These are not positional isomers. These are metamers. And after that we will see another class, that is aldehyde and ketone. So if you think that this is propane 2 on, this one is propane 2 on, and molecular formula of this is C3H6O. And if you want to draw one more compound over here, CH3, like this. This is also C3H6O, but this is propanol. This compound is propanol. The difference over here is this is having one side hydrogen and another side carbon. So it is an aldehyde. It is having both side carbon, so it is keto group. So keto and aldehyde functional group isomers we are seeing over here. And if we want to draw a functional group isomer of this, it is not possible because we cannot form a keto group. The smallest keto group is 3-membered. Clear or not this thing? For ketone, this is the smallest number which can be present over here. We don't have ethanol. Clear or not? So this thing that this one and this one, they don't show functional isomers with ketone. But the higher member chain, they are going to show the functional group isomerism. Like this. This one will show. Okay, no, it's not a better way. If we are yes, if we are having like this 1 2 3 4 5 6, it is a 6-member chain, and the name of this compound is hexanal. No need to write one because we are quite sure that it is at position 1, so we can skip also that thing. So it is hexanal, and if you want to draw the functional group isomers of this keto functional group isomers, it will be like this. 6 double bond at this position. The name of this compound is hexane 2-on. Can we draw some other possibilities? One, two, three, four, five, six, like this. So these are the two possibilities. 2 position and 3 position. Hexane 2-on and hexane 3-on. So if you think over there, that can we have a hexane 4-on? 1 2 3 4 5 6. So if you draw this, then you are doing a great mistake. It is not hexane 4-on, but the numbering will be from this side 1 2 3. It is a hexane 3-on. They both are same. Clear or not? So by this way we are studying the nomenclature also and functional group also, isomerism. With that also we can see this is at 2 position and this is at 3rd position. So these two are position isomers that we have already studied in the previous lecture in quite detail. In previous video you can go over there and watch this in quite detail regarding this positional isomers. So if you are going to see some more isomerism, like simple in alkene and alkyne, they also show a functional group isomerism. So in such compound, what we are going to see, one, two, three, four, 5. The name of this compound will be pant 1, 1,4 diene. Pant 1,4 diene. And if you are the yes. So if we want to see a functional group isomer of this compound, it is a 1 2 3 5 carbon are there. 1 2 3 4 5. 1 2 3 4 5. So can we draw like this one triple bond over here? Clear? CH, CH2, CH2, CH3. So you can say the numbering of this will be like C5, H3 to 5 to 7 or 1 8. C5H8. This is the molecular formula for these. 2 or 1 3 to 5 or 1 6 or 2 8. C5H8. So these two are functional group isomerism. This one is ene and this one is ine. One more thing you can see over here or visualize that this is a position 1. The name of this compound is pant 1 ine. So can we draw a same position isomers which we have discussed in the previous class of this compound? Then we can see over here that 1 2 3 4 5 3 3 6 or 2 8. So this is also a functional group isomer for this compound. This is pent2-ine. And if you want to draw pent3-ine, that will be like this. 1, 2, 3, 4, 5. So, but this is also not a right name. This will be number from this side, 1, 2. So this is pent2-ine. So these two are same compound only. And what is the relation between these two? These two are positional isomers. So we are also doing a quick revision of positional isomers in this functional group isomerism. So we have discussed regarding alcohol and ether, regarding aldehyde and ketone, and we have also discussed this alkene and alkyne. So now we will be discussing regarding some more groups like amines and alcohols. Don't be confused that I am going to make a functional group isomerism between alkene and amine and alcohol. Just we are going to discuss both of them as combinedly. If we are having CH3, CH2, 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 NH2. 1, 2, 3, 4, 5. It is a pentane 1-amine. This compound name is pentane 1-amine, and if we want to draw some functional group isomers of this compound, this can be like N-methyl butanamine. And another isomers which can be drawn from this 1, 2, third one will be CH3, CH2, and CH2, CH2, CH3. The name of this compound will be N-ethyl propanamine. Can we have some more possibility? So if we are trying to draw propane over here, it will become ethane like this. I will just show you. If we are going to try to draw this, and so here only two members will be remaining. So this one and this one, they are same. Clear? CH3, CH2, 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 CH3. Clear or not? So this is like primary amine. This one is primary amine, and these are secondary amine. So this one and this one, if you see regarding the relation, so we can see over here 1 and 2, 1 and 3, these are functional group isomers, because it is one primary, this is secondary amine, this is primary, and this is secondary amine. But if you see over here, this type of group, these two and 3, the relation between 2 and 3 is metamers. These two are metamers. We will discuss this in our next video. That would be more appropriate. We are not going to mix up all these isomers over here. Just we are going to discuss the functional group isomers in this video, and those which we have discussed earlier, that I am just taking you like chain isomers and position isomers. This metamers we are going to discuss in the next upcoming video. So one more thing regarding there are 5 carbon, yes. So what we can, one more thing we can do is N CS2 CS3 CS2 CS3 N methyl N ethyl N methyl ethane amine. This is like if you say 1, 2, 3, fourth one. We are moving in the continuation only. This one is fourth one. So this 4 one is this 1 and 4. They are also functional group isomers. This 1 and 4, they are also functional group isomers. And regarding, can we have some more possibility in this? Yes. Sorry. So this one is N dimethyl N dimethyl methane ethane propanamine. So this is, let's say, fifth one. So we can say over here 1 and 5th are also functional group isomers. So in this way we can draw these functional group isomers. So you need to know these primary amines, secondary amine and tertiary, and these are functional group isomers. But one thing which I need to clear, it depends on this nitrogen. This nitrogen should be disubstituted, monosubstituted and trisubstituted. That is the thing. If we are having a chain like this, NH2, NH2, NH2. These are not functional group isomers. This need to be clear. These are 3, like, okay, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. Yes. So these are having the same molecular formula, different structure formula. They are not functional group isomers because they are having all are 1 degree amine, or you can say the amine is NH2. There is not disubstituted or trisubstituted amine. Mono, di, tri. That are different functional group. These are not. These are attached to a tertiary carbon, secondary carbon and primary carbon. So these are not functional group. They can be like chain isomers. This thing we have studied in the quiet details. So you can go through the chain isomerism and this see over here this type of isomerism. So regarding the carboxylic acid and isomers of carboxylic acid, just I will show you one example: CS3, CS2, COOH, or CS3O, C double bond O, CS3. Methyl ethanoate and propanoic acid. These two are also functional group isomerism. Methane, ethane, propanoic acid and methyl ethanoate. Propanoic acid. This one is propanoic acid and this is methyl ethanoate. And many more examples can be drawn for such type of isomerism, like if we are having COH or CS3O, C double bond O, CS2, 1, 2, 3, 4, 5. So 1, 2, 3, 4. So this will be like pentanoic acid, and this one is going to be methyl. This one is going to be methyl, methane, ethane, propane, butanoate. Methyl butanoate. So can we draw some other possibility of this? Yes. We can draw a more possibility like CH3, CH2O, CO, CH2, CH3. 1, 2, 3. Ethyl propanoate. Or we can say propyl ethanoate. One more possibility. This will be like propyl ethanoate. So in this way we can draw a various functional group isomers. So this 1, 2, 3, sorry, I'm really sorry, yeah. This is 1, 2, this one is 3, this one is 4. This 1 is isomers is 1 and 2, 1 and 3, 1 and 4. These are functional group isomers. So I have drawn this whole slide. So there are enormous number of examples which we can draw over here. CH3 and double bond OO. What does the name of this compound? Nitromethane. This compound is nitromethane. And if we are going to chain CH3O and double bond O, this one. So this will be methyl nitrite. This is going to be methyl nitrite. So these two are also functional group isomers. So a very interesting example which I am going to show over here. And what is the relation between these two compounds? What is the relation between these two compounds? So if you see the molecular formula over here, 1, 2, 3, 4, 5, 6, 7 carbon. Over here also 1, 2, 3, 4, 5, 6, 7 carbon. Hydrogen are there 1, 2, 3, 4, 5, 6, 7, 8. H8, 5 or 3, 4 or 1, 5 or 3, 8. And oxygen 1. C7, H8O. This is the molecular formula. Both are having same structural formula. Are these two different functional group or not? This is methanol, or you can say this is alcohol, and this is directly attached to a phenyl ring. This is phenol. So these two are also functional group isomers. Don't be confused that alcohol and phenol, they are two different functional groups. So this one and this one, they are different functional group. So they are different functional group isomers. So we will be doing a quick summary of what we have discussed in the today's class. So earlier I told you, if you want to discuss regarding the chain and position isomers, you can watch our previous videos in which we have discussed in quite detail regarding chain and position isomers. Today we are going to discuss regarding the functional isomers. In that I have just discussed regarding the alcohol and ethers, regarding the different functional group isomers. Over here keto, aldehyde and ketones. Over here in those two slides, alkene and alkyne, Ne, ALKYNE, alkene and alkyne, amine and alcohols. Regarding the different functional group isomers of alcohol and amine, like phenol and alcohol. This thing I have clarified, these are not functional group isomers. They are not functional group isomers, but chain isomers. Regarding this acid and ester, and regarding this alcohol and phenol, In the next slide, we will be discussing a subclass of this functional group isomers, ring chain isomers and metamers. And if time permits, we will also discuss a bit regarding tautomers or tautomerism. So that's all for today. Thank you.